Jimmy rented a car for a flat fee plus $2.50 per mile. His total bill for traveling 85 miles was $342.50. How much is the flat fee? So I'm going to first start off thinking about the situation, and in this case we've got a flat fee and we've got a $2.50 per mile. So I'm going to write that down. We've got the flat fee. I'm going to write that in words because I don't know what it is yet. And then I know we're also going to have to add $2.50 times however many miles he travels. So I know I would multiply $2.50 times the number of miles. So I'm going to show that, and I'm going to use the word miles. So that flat fee and then the $2.50 per mile, we're going to add those together, and that gives us the total cost. So I'm going to write that also. What I've just done is create a word equation about this situation. Now I'm going to look back and say, hey, there's some more information here. It says if his total bill for traveling 85 miles. So it's telling us the miles is 85, and this is miles right here. So I'm going to write 85 because I know miles is 85. It just told me that. And it also tells me the total bill is $342.50. Well, that's the total bill, that's the total cost. This is the total cost right here. So I'm going to write $342.50 right there because that's the total cost. So we just put in some additional information. So I'm going to go back and rewrite the other pieces of my equation that are here. See, there's an equal sign right here, so I'm going to write my equal sign. And then this is $2.50. I'm going to write that. And then I see that the 250 is multiplying times the miles, so I'm going to put the parentheses on there. And then there was a plus right here. I'm going to write the plus. I'm just kind of randomly putting these where I see them above. And then I see that there's a flat fee, but it doesn't tell me the flat fee, and I don't know what that is, so that's going to be my variable. So I can put any variable I want in here, and I always like to use x because that's kind of the most common variable. So that's the thing that I don't know, and so I know I'm going to go and define my variable. X is going to be the flat fee, the amount of the flat fee. I can put dollars there. And then I look back at my question and I say, look at that. How much is the flat fee? That's what it's asking. I see the question mark. And that's exactly the thing that we don't know, and that's what our variable is going to be. So look, we've created our algebra equation, starting first with words, and then creating our equation, and then saying what the variable is for the one thing that's missing. Now to go ahead and solve this, I'm ready to go, and I realize I want to get x by itself, so I can see right here, here's my x, I'm going to draw my line, and this is my variable right here. I want to get it by itself, but then I notice when I go to undo that this is not totally simplified. I need to do that multiplication before I do any undoing. So I'm going to rewrite x plus, and then I'm going to do $2.50 times 85. So I'm going to get out my handy calculator. I'm not going to write that down and show the computation because I'm going to just do it on the calculator, and I get $212.50. And so I write that down, and then I write $342.50, and now I go to get the x by itself, and I realize there's a constant with it, so I'm going to undo that constant by doing the opposite number, so negative $212.50 on each side, and then I do my simplifying, and I write plus $212.50 minus $212.50 makes 0, so what's left over here is x, and then I do $342.50 minus $212.50 in my calculator, and I get 130. And so then what does that mean? I don't know. What's x? Oh, I look back up here and it tells me that's the flat fee. And then I realize my question was asking, what's the flat fee? So that's my answer. So I'm just answering it just like it asks. It says, hey, how much is the flat fee? And so I answer, oh, the flat fee is $130. So that's how I write my sentence. The flat fee is $130. All right. All right, this next one, the mountain climber was at the top of a mountain, which was 9,250 feet above sea level. Each hour he hiked, he descended another 175 feet. Where would he be after 4.5 hours? So I know that I'm going to have a starting point, right? We're going to think of this as a timeline going left to right, right? Our timeline. And so I know there's always going to be a starting point. So I'm going to write start. Where is he at the start? And I can see that he's 9,250 feet above sea level at the start. So I'm going to write that. I kind of liked writing the word initially to give me an idea if that's what's going on. And then we know that something happens repeatedly, right? Each hour, he's going to descend another 175 feet. So we know that's going down 175 each hour. So I'm going to write hour in parentheses, because that's what's happening each hour. And then I know that there's going to be, he's going to end up somewhere. So this is the ending location, right? This is the starting location. I can write the word location in there. So we got the starting location, and then he goes down 175 each hour, or she, and then we've got the ending location. So now let's look and see what other information we're given in the problem. Where would he be after 4.5 hours? Well, that's helpful. Hours. I see that's right here. So I can replace that with 4.5. And so I don't see any other information. So I'm going to go ahead and rewrite the rest of my thing. I had the hours was in parentheses, and the minus 175 was right before that, and before that was 9,250. So I'm rewriting exactly like what's above. And then I said equals, and then the ending location. Well, we don't know that, so I'm going to call that my variable. Now, I'm calling that x. Maybe you're calling that y. It doesn't really matter. You can call that anything you want. You could call it p. You could call it n. You could call it x. You could call it y. You could call it w. So, whatever you call it, that's how you just have to use that same letter when you define it. So, what's that standing for? That's going to be standing for the ending location, right? That's the ending location of the hiker, right? And you could just put the location of the hiker. You don't have to necessarily use the word ending in there. And you can look and see that it matches our question. Where would he be, right? That's the location, right? That's where he would be. So now we've got our beautiful algebra equation, and we're going to go ahead and solve it. And so when I realize I go to solve it, the x is already by itself over here. So all I need to do is order of operations. So I'm going to do order of operations. I'm going to rewrite 9,250, and then I'm going to do that multiplication, 175 times 4.5. Back to my wonderful calculator. And I get 787.5 equals x. So now I'm going to do the subtraction. So 9,250 minus 787 is going to be 8462.5 equals x. So what is that? Is that how long the hiker was hiking? No, we're going to look back and look at what our x is defined as. The location of the hiker, and that's matching our question. So I would say after 4.5 hours, the hiker would be at 8,462.5 feet, and that's above sea level. All right. All right, we're going to do one more. Mrs. Smith had a large jar of candy. Every day she gave out a piece to all 27 of the students in her class. After giving out candy for 16 days, this is a bad idea, by the way, she shouldn't be giving out candy. Okay, after giving out candy for 16 days, she had just 5 pieces left in the jar. How much did she have in the jar to start with? So let's think about what's going on. So she starts out, we always think of our timeline left to right. At the beginning, how much did she have at the beginning? Doesn't tell us. So I'm going to write that starting amount of candy. And then what happens? She gives out candy from her jar. So she's taking it away from her jar, and she gives out 20 students. She gives out pieces to her 27 students. So she's going to subtract 27 pieces every day for each day. So I'm going to put, she subtracts 27 times the number of days. And then that's going to give her what's left over in the jar. Right? That's kind of like our ending amount, or what's left over. Right? I just think about the situation, and I don't make it all mathy. I just do it according to what's happening. And so now I go back and say, is there more information in the problem? And there is. It says she gives out candy for 16 days. So I go and say days. Oh, that's 16, and I put that in there. And then I say, what else? Oh, 5 pieces left in the jar. Just 5 pieces left. That's the ending amount over here, 5. So I'm going to fill that in. And then it doesn't tell me anything else. So I go back and I refill everything that's going on. I see the equal sign. I put the parentheses around days. We've got the 27 and the minus. The only thing that's missing is the starting amount. So here's the starting amount, and I'm going to make that to be X. So X is going to stand for the starting number of candy in the jar. So now I go to solve for X, and I say, here's my X. I want to get it by itself. So I've got to first simplify this amount right here. X minus 27 times 16 is 432 equals 5. And then I see my constant is negative 432, so I'm going to do positive 432 on each side. And I get X equals 437. And so I know, what do we see here? X, starting amount of candy in the jar. Question is, how much did she have in the jar to start with? So I know that's my answer. She had 437 pieces in the jar at the start, or at the beginning. Let's take a look at this one. Cindy bought a bracelet for $14.65 and 6 scrunchies, and her total bill was $27.85. If they were all the same price, how much did each scrunchie cost? So let's think about this. She's going to buy a bracelet, plus she's going to buy 6 scrunchies. So I'm going to do 6 times the scrunchies, how much they cost, and this is the cost of the bracelet. So we have the bracelet money plus 6 times the number of scrunchies, and that's going to give us her total cost, bracelet and scrunchies. So now let's see what else we know. It tells us the bracelet was $14.65, so I can put that in here, $14.65. And then it tells me, oh, her total bill was $27.85. So that's right here, the total cost, $27.85. So let's go ahead and fill in what else. We don't know anything else, so I'm going to go ahead and write the rest. I see a plus right here, so I'm going to write a plus. I see a 6, so I'm going to write a 6 times the scrunchies. We don't know the scrunchies. That's our question. How much did each scrunchie cost? So that's going to be our variable. So I'm going to write it like this, X. And then I'm going to write equals, because I see my equal sign right here. There's a beautiful algebra equation. What don't we know? We don't know the scrunchies, the cost of the scrunchies. So I'm going to write X equals cost of 1 scrunchie. That's a little thing to tie your hair with. So now I'm going to rewrite this equation so it's a little bit closer together. 6x equals 2785. So now I want to get the x by itself. The first thing I'm going to do is deal with my constant by writing the opposite value, which is a negative 1465. So now I'm going to do that on my calculator. And I get 13.26x equals 13.20. And I'm going to divide each side by 6. All right. Well, connection problem there, so I'm not sure what got skipped. But I'm going to keep working on this problem. So perhaps some of the solving got left out, but that's okay. So I'm going to divide each side by 6. And now I'm going to divide 1320 divided by 6. And I get 2.2. And so what does that mean? Well, I'm looking and it says X is the cost of one scrunchie. And that's what it's asking me. So I'm going to write each scrunchie costs. I'm going to write this as money. I'm not going to write 2.2. That's not how money is written. $2.20. All right.